positive numbers A and B is the positive number X that satisfies the following proportion. Okay, so it's a weird proportion. Just write it down. We'll talk about it in a second. A divided by X equals X divided by B. So the A and the B are the two values that you're trying to find the geometric mean of. And then when you actually solve the proportion, that's your geometric mean or the geometric average of your two numbers. So if this was just a regular proportion, how would I solve this proportion? What would I have to do? Yeah, I'd have to cross multiply. Now, what is X times X? X squared. X plus X is 2X. X times X is X squared. What's A times B? It's AB, yeah. Or you can put A times B. Yep, exactly what it is. And so what I would have to do there is then solve for X. Now, how do you get rid of squaring something? What's the opposite of squaring something? Square root, yeah. So I'm going to have to square root both sides. It's not division because division goes with multiplication. This is squaring. So at the end, whatever your X value is essentially the square root of your A times B value. And the A and the B are just numbers. I know that this looks strange, but in a second, we're going to do an example. You're going to be like, that's it? Super easy. Okay, so we're going to find the geometric mean of the numbers listed there. Now, excuse me, when we're doing geometric mean, I need two proportions. And the two numbers that I'm trying to determine, these are considered my A and my B value. These two have to go diagonally from each other. So 45 would go on the top, and then 5 would go diagonal from it. It does not matter which one's where. The other two numbers are going to be X, because that's going to be the value I'm trying to solve for my geometric mean. And now we do cross multiplication. So X times X is X squared equals 45 times 5 is 225. To get the X by itself, I square root both sides. So the square root and the square cancel each other out, these pieces. You're just left with X equals, and do you remember how to put 225 into your calculator? Square root of 225. Shift, yeah. So you're gonna put, and you do, I'm gonna ask that you use the calculators because when it comes to like a test, you can't use your phone, right? And so I want you to get into the habit of using the calculator now. So when a test time comes, you feel good about it. So you put in the number 225, and then you push shift, and then the X squared. So if you want to get to anything in yellow, just for future reference, anything in yellow, you have to push the shift button first. Okay, so you push shift, X squared, your answer is 15. So that means 15 is the geometric mean of 45 and 5. That's it. Easy peasy, right? Okay, do you think you could do the next 3? Yeah. All right, try the next 3. Let's see if we get the same answer. So I'll give you a couple minutes. See how we do.
I'm guessing we can't put a decimal.
You can definitely get a decimal. Why not?
Like a big decimal?
Yeah, why not? What's wrong with that? Okay. Because they're not all going to be perfect squares, so. Decimals are fine. You can round to either the nearest tenth or hundredth this time. So 1 or 2 decimal places. You don't really need to go further than that, unless you really want to. But that's how I want to work. And then when you're done, just put your pencil down so now you're ready to rumble on to the next piece. Okay, what did you get as the geometric mean between 6 and 24? 12, beautiful. Anybody not get 12? 6 times 24, square root, yeah? Doing okay? All right. What about the geometric mean of 4 and 12? What'd you get? 6.93. Good. Now maybe you rounded it to just 6.9. That's fine. That's cool. But what you do need to do is, because you rounded and it's not an exact answer, we've got the approximate symbol here, which is like the 2 squiggly lines. You don't want to put an equal sign because that means that it's exactly that answer. Because we rounded, we want to put approximately. So anytime you round, I am going to ask that you put the approximate sign to show that it's not like an exact number. Okay. So about 6.93, or if you put 6.9, that's cool too. Okay. What about the geometric mean between 15 and 45? What'd you get for the next one? About 25.98. Maybe you rounded up to be about 26. Maybe you wrote more decimal places. But again, even if you put 26, you rounded, so you need to put an approximate symbol. Okay, so anytime it's not exact, you better have an approximate symbol. Okay. All right, easy peasy, right? Geometric mean, easy stuff. Now, we're going to take that idea and we're going to find geometric mean of similar triangles, so some of the side lengths. We're going to take the exact same idea, we're just going to put a picture to it. Okay, but it's the exact same thing. So let's open it up to our first theorem. So we got 2 theorems today. First one is the altitude theorem. Can I have somebody read that like little blurb there for me, please? I want to read. Hey, go for it. Nice and loud, please.
In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the length of the 2 segments.
Okay, that was a lot of words in there, right? There's a lot of things going on in that sentence. So I'm going to take my first color, and I'm going to use the same color for all of my altitude problems, okay? So the altitude is the piece in this triangle that is kind of like dividing up the bigger triangle. So in this picture, you really have 3 triangles, right? You've got the really big one, A, B, C, that's the big triangle. And then you've got a small triangle on the left, ABD, and a small triangle on the right, or like a medium-sized one, ADC, okay? The altitude is the piece that's dividing them up into smaller pieces, or to smaller triangles. So in my picture here, the altitude is this piece right here, AD. In my particular problem, it's X. So the length of the altitude is the geometric mean of the lengths of the 2 segments. So what that means is your altitude, this piece here, we're going to put it into the proportion, and whatever this altitude is, it is the 2 diagonals that are across from each other. They should match up. So in my problem here, I'm going to put X and X because that's my altitude. Now, the other 2 pieces that I put are the 2 segments that make up the hypotenuse. So do you guys remember last week when we had the bisector problems? We took the angle and we picked the 2 sides that were across from the angle.
Yeah.
that's pretty much the same thing we're going to do here. We're going to take the big triangle. We're going to go to the 90-degree angle, and we're going to pick the two pieces across from the 90 degrees in the big triangle. So if I'm looking at this whole big triangle, okay, if I go to the 90 degrees here, what are the names of the two pieces across from the 90? Okay. Perfect. So this piece, BD, and this piece, DC, are going to be the other two diagonals, and it doesn't matter where they go as long as they're diagonal from one another. So BD and DC. In total, this whole piece, BC, the whole thing is called the hypotenuse, the longest side of the triangle. Okay, so we go to the 90, we go across from it. The two segments across from the 90 will be diagonal, and then the piece of the altitude will also be diagonal. Okay, so let's try an example. Number 1, we're going to find x for each of these problems. So I'm going to set it up, and here's what I always do when I write my proportions. I draw the two proportions out, and then I highlight the two pieces that should match up. And I do this before I even look at the picture. If I know it's an altitude problem, that's how I start it off. And then I go, okay, what piece is the altitude in my problem? So in number 1, what number is my altitude? AD, which is what? It's just x. So in the two highlighted pieces, I'm going to put x's. The other two are the two segments that make up the hypotenuse. What are the two other segments? 2 and 50. It does not matter which one goes where because you're going to multiply them anyway. And then, yeah, it's exactly the same as the front. Now we just cross multiply just like we did on the front side. So x times x gives me squared. 2 times 50 gives me 100. And then if I take the square root of both sides, I get x equals 10. That's it. That's the whole thing. Whoa, that was it. Geometric mean, man. Okay, do you think you could do? You probably could do the next 3, don't you think?
Yeah.
Maybe. All right, give the next 3 a try and we'll check them. We'll see how we do. So try 2, 3, and 4. We'll see what we do. Yeah. Yeah. And remember, if you are rounding, make sure you're putting an approximate sign.
Good setup. Good setup. That was good. Perfect.
What?
Perfect.
Is that the answer?
Did you solve it?
Do I have to?
You gotta get x by itself. What's your altitude in this problem?
Oh.
Make a little change, eh? Yeah, make a little change.
So do I have x squared?
No, this one has to be.
Um,
There, perfect. Well, look, this is just 36 equals 8x. How do you get?
Oh, so you just do that other thing.
What? Yeah, just like a regular equation, yeah.
I just didn't know.
No, you're okay. A little bit of a trick, right?
Yeah. Okay, so this is just a regular equation. Then this is equals 8x. How would you get it small time?
Yes. Beautiful. Good, good. Looking good. Yeah. Okay, ready to check them? You need another second. Don't all jump up at once to answer. Okay, cool. What'd you get for number 2? Okay, around 8.9, maybe you put 8.94, maybe you put, well, I don't know what else you might have put. But be careful with that one. I gave you the whole thing was 18, right? So the 2 pieces that make it up are 8 and 10. Don't use the 18 in there. Don't be tricked. Don't be fooled. All right, the 2 pieces are 8 and 10. Cool. All right. What about number 3? What'd you get for number 3?
4.5.
Steve, you got 4.5. Do we agree or disagree with him? Agree. Beautiful. Okay, so for number 3, right, the 6's were the altitude. Oops, the 6's were the altitude. They matched up with each other, right? And then 8 times x was the other side. And then you had 8x equals 36. It just was an algebra problem. You divide both sides by 8, you get 4.5. And that was an exact 4.5, so I put an equal sign there. It's exactly 4.5. Okay, number 4 was the same kind of setup. What'd you get for number 4? 2.083. Maybe you did it to 2.08. Maybe you did 2.1. Something close. Wonderful. And again, you're rounding that one, which means you need the approximate symbol. So if you didn't put the approximate, fix it and write the approximate symbols. Okay, there you go. You just did one of the theorems. What do you think? It's like really easy, right? It's almost too easy.
Now you're gonna make it hard.
No. Why does everybody think that? All day, everybody's been like, now it's gonna get hard. Like, no.
That's literally how math works.
Not much. We keep it easy. All right. Questions on that one? How do you feel? Feel okay? All right, let's try the next one then. Geometric mean. This one is called the Hypotenuse Leg Theorem. Can I have somebody read the second paragraph there for me? I don't need the first paragraph, but the second paragraph. Anyone at all? Not eggs. You already read 3 million things today. Shereen, go for it.
The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Okay, so don't let this one trip you up. It's a little bit different because what you're going to see is the altitude is not given to you, right? This altitude is not there. So we need to come up with another way to solve for the side lengths that are unknown. Now, this is where I'm going to take my next 2 colors, okay? So, new color here. I'm going to start by highlighting the biggest triangle in this picture. What's the biggest triangle in this picture? ABC. Okay, so I'm going to highlight ABC. I'm going to put it in this first box here. Now, this fraction becomes, I have to take the hypotenuse, which is the longest side, and divide it by the leg that is the segment that is adjacent to the hypotenuse. So the one that is touching the hypotenuse. So if you're looking at this pink triangle, which side is the longest side of the triangle? Which is which one? BC, right? It's across from the 90, BC. Now, I need the full hypotenuse.
What's the whole hypotenuse? 10. How'd you get that?
Because the two sections of the triangle are 2 and 8, and you just have to get 10.
Yep, you just add them together, you get 10. Okay. So you've used up the hypotenuse. The leg is the other side you're trying to find, and the only other one that's got a letter on it is which one? X, the AB side, right? So this one is right next to the hypotenuse. That goes below. 10 over X. Now, your next triangle you're going to pick is on the interior, and you must pick the triangle that uses the same variable. So between the right and the left triangle, which one are you going to pick? ADB, the left triangle, because this one has the X value with it. Now, I need to do the same thing. I need to divide the hypotenuse divided by the leg of the green triangle. If you're looking at the green triangle, which side is the hypotenuse? X. Yeah, side AB is the hypotenuse. It should match up diagonally with this piece over here. What's the only other side given to you in that green triangle? 2. So that would be your setup, and then you'd go through and you would obviously do the same thing we've been doing. So the hardest part of this one is just making sure you set it up correctly. Hypotenuse leg, hypotenuse leg. All right, you ready to try an example? Okay. Obviously, you would finish that one. I'm not going to finish that one. So let's take a look at number 5. I'm going to start with my full triangle, my big triangle, and I'm going to do hypotenuse over leg for the pink triangle. Notice I kind of do the same thing over and over again. Okay. What is the longest side of the pink triangle? It's still BC. It hasn't changed. What's the length of BC? 16. Divided by, what's the other leg of the pink triangle that I'm trying to find? X. Yeah. Okay, now when I go to pick my green triangle, am I going to pick the triangle on the left or the triangle on the right? On the right, because that's the one with the X. What's the hypotenuse of the green triangle? Oh, careful now. So if we're looking at the green triangle, the hypotenuse is the one across from the 90. So it's X, yeah. Over, what's the other piece of the green triangle? 4, yeah. And there's your setup. 16 over X equals X over 4. And then we cross multiply. So X times X is X squared. 16 times 4 is 64. And then we square root. X equals 8. So it's the exact same thing as the front side. The only hard part about this is just making sure you pick the right numbers. Okay, I want you to do 6 and 7. We'll see if we get the same thing. 6 and 7, yes.
So why do we have to do the whole, 16 instead of, subtracting 4?
Because we're looking at the whole big triangle first. So when we write the equation, when we write the geometric mean, we always look for the biggest triangle first, and then we pick the smaller one that matches up with it. So yeah, that's why we have the 16 there. It's the whole triangle. Good question. Yep, 6 and 7. I mean, if you want to try the other two, you're welcome to.
So how do I set up 6?
Well, you take your big triangle
Okay.
and you take the hypotenuse of the big triangle. What's the hypotenuse of that really big triangle?
25.
The whole triangle. That's not the whole triangle.
45.
Ah, 45.
25 on the other.
Correct.
And then I put the X.
Correct. Yes.
Okay.
You're welcome. Nice catch. Remember to put the approximate sign if you are rounding.
It's not gonna get harder, she says.
Huh?
It's not gonna get harder.
I don't think this is any harder. You just have to be careful. It's still geometric
Be
mean.
careful. It's like you didn't have to be careful on the other one.
Well, because on the other ones, I only gave you the numbers that you needed.
Exactly.
This is also true. I'm still only giving you the numbers that you need, but
Need to think this time.
yeah, it causes a little bit of thinking.
You don't like thinking.
Oh, that seems unfortunate for you.
It causes my IQ to increase.
Ugh,
What a shame.
it's becoming a better human member of society.
I mean, like, nothing proves that having a higher IQ means you're better person.
Oh my gosh.
If you really
Let's not pick and prod at that, friend. Okay, we ready? What'd you get for 6? Beautiful. About 33.5. So depending on how you round it is fine. But the whole hypotenuse is 45. You have to add the two together over x, and then you pick the triangle on the right, so it's x over 25. Beautiful. So be careful not to fall from a trick. Make sure you add the two together to get the whole side length. Okay, what did you get for number 7? About 5.3. You got 5.29 or whatever the number, next number was, something close to 5.3. You're good to go. Okay, now the last two that are left, why are they a little bit different? They have y's, which means you're going to have to do both an altitude and a geometric mean with the leg as well. That means you're going to have to do 2 different steps. Oh no.
It's not gonna get hard.
That's as hard as it gets right there. That's literally the hardest it gets.
Really?
You're looking at it.
Really?
I
And
swear
do
to
it.
God, that's the hardest it gets right
Give
there.
us 2 examples
That's still
of
getting
it.
harder.
There it is, right there.
No.
No, there it is.
No, you do it though, together.
No. You're going to attempt those 2 on your own. We're going to check them tomorrow.
Yeah.
Dang. Okay, so you try those 2. Tomorrow we're gonna have an exam, or we're gonna have a practice with it on Canvas. So bring your computers tomorrow. Okay, you guys did a lovely job today. Lovely, lovely. And we will continue on tomorrow.